So I gave you guys an assignment. I said that how many bond and lone pair does the following each have. So I'll be explaining everything about bond pair and lone pair better in this video, so you guys should just pay attention. After this, I'm sure you all should know it now. After this explanation, now I asked for the bond pair of boron, neon, carbon, fluorine, oxygen, and helium. Now take note that any element that is not combining, the bond pair is usually 0. Any element that is not combining, the bond pair is usually 0, and the lone pair is always what visible only if the valence electron is greater than 4. What it's just trying to say is that let's using K element. Let's use K element, KLMN. When we are using this shell. Now let's bring boron. Now boron is what in the periodic table, number what? We have hydrogen, helium, lithium, beryllium, boron. Boron is number 5 in the periodic table. You can see it here. It's number 5 in the what periodic table. So boron is number 5 in the periodic table. Now let's bring out our shell. So it has an electronic configuration of what? 2, 3. You get 2, 3, which is KL, right? 2, 3, which is KL. Are you getting? So now we have 2, 3 in the periodic table. Now let's make our electronic configuration. So we have small. So inside here we have our 2, which is 1, 2. So we have to draw a bigger one. We have our 3. Sorry. We have our 3. Can you see it? 1, 2, 3. Can you see it here? So now it is complete. Now this one belongs to the what? Hell shell, right? So if I were to draw it, you can see it here. If I were to draw it, you can see, so this is 1 S2. So you have 1 S2, Abby. So 1 S2. You have something like this. We have our 2 S2, Abby. We have something like this. Sorry, 2S1. 2S1. So we have something like this. No, it's 5. Sorry, it's 5. So we have 2S2. It's 5. So this is for that. So now we have to draw for the P. For the P. Now take note that your P usually have your P orbital usually have how will I put it? Your P usually have what? 3 space to fill. 1, 2. So it has 1, 2, 3. It has 3 space to fill. Take note. Your P orbital usually have 3 space to fill. Take note that your P orbital, as I'm explaining based on shell and orbital, your P orbital and this orbital, your P and S orbital is always in your what? In your outermost shell. You get? So your P orbital is the valence electron. Take note. The P orbital is the valence electron. Anything the P orbital is what? Valence electron. So we have what? 1. It has stopped already. We have 2 plus 2, 2P1. 2 plus 2 plus 1. Can you see it's complete? 2 plus 2, 4. 4 plus 1, 5. Can you see it's complete? Now, how many bond pair does this thing have? How many bond pair does it have? It has no bond pair. Remember I said any element that is not combining does not have any bond pair. You can see boron, it is not combining with another element. If it's beryllium chloride now, you get. If it is sodium hydroxide now, you get. But this one, boron, it is alone, so it does not have any bond pair. Now let's check whether it has lone pair. It does not have any lone pair too. For it to have lone pair is based on the what? Outer shell. Take note, lone pair is based on the what? Outer electron. That's why your lone pair is based on. Your lone pair is based on your what? Outer valence shell. Now you can see here that it does not have any lone pair because it is not combined and it is not even complete. It needs 1 year to be complete. Even if it is complete, it does not still have lone pair. It has to combine again to have lone pair. Let me give you another example. Let's use neon, so you get what I'm trying to say. Let's use neon as an example. So now see, you have neon here. So neon is number 10 in the periodic table, Abby, with an electronic configuration of what? 2, 8. Can you see? With an electronic configuration of 2, 8. So now let's draw it. So we have what? We have something like this. 1, 2. Now this is for the 2 inside. Then we'll draw a bigger one. Draw a bigger one. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, Can you see it? Sorry for my my drawing is rubbish. So you draw another one. Now you can see it here. 1, 2, 3, 4. It's not yet complete. You still need another 4 to complete it, Abby. So you have 1, 2, 3, 4. So now it is complete. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that union is complete. Now, you know I said your lone pair is based on the what number of what valence electron, your outer shell. So let's count it. So now we have how many lone pair? We have 1, 2, 3, 4. So we have 4 lone pair and 0 bond pair. Can you see this thing? So we have our 4 lone pair and we have what 0 bond pair. Can you see it? 4 lone pair and 0 bond pair. So any element that is not combining with another element usually have 0 bond pair, but it can have lone pair. It does not have any lone pair when it is lower than 4. See now, you can see in the boron here we only have 1, 2, 3. It is not up to 4, so it does not even have any lone pair. So it has to be greater than 4 for it to have lone pair. Even if it is 4, still it does not have any lone pair. It must be greater than 4 before it can be having lone pair. Do you get? Because if it is not greater than 4, it's not be able to combine with another with another electron to form anything. So it even has to be greater than 4 before it can have a lone pair. Are you getting the point? So you can see here we have 4 lone pair and 0 bond pair because we have what number 4 electrons in the atom shell. So let me draw it for you. So we have an electron of 1s2, 2s2, 2p, 2p6, Abby? I think so. 1s 2 plus 2 4, 6 plus 4 10, Abby? 2 plus 2 is 4, and 6 plus 4 is 10. So we have 2p6. So what you have here is what? Let's draw it. So about here. So now this 1s2 is for this one inside here. Take note. This one I'm drawing here is for this one inside here. So you have a 1s2. Now let's move further. We have a 1, 2. Now this take note that the k, this one is for our KL. So it's for our L shell. Our L shell. This is for the K shell. So this one is the K shell. This one is the what? L shell. So this one and this one is for your L shell. Why this one is for your K shell? Take note. So let's draw for P. Sorry, there's no space here again. So for P, we have 3 space 1, 2. So let's draw it 1, 2, 3, 4, 5, 6. So can you see it has bonded completely? You can see here. So it has what? It has about what? It has how many lone pair? 1, 2, 3, 4. It has what? 4 lone pair and what? 0 bond pair. 1, 2. You can see it here. It has bonded finish. So this is what's configured. So this is what you are going to use to get it. You are going to use this kind of configuration to get it. So let me explain something else with another video.